Okay, assalamualaikum and hi guys. Now let's move on to the next subtopics. Which is 3.4 Laplace transform of direct delta function. So before we go to the Laplace transform of direct delta function, let's see the definition of direct delta function. Okay, so the direct delta function, which is given by this notation delta t minus a, is defined by a piecewise function of infinity and 0, where for infinity if the t is equals to a and 0 if otherwise, and the improper integral from 0 to infinity delta t minus a dt is equals to 1. This is formula and the improper integral of ft delta t minus a dt is equals to fa. If you have ft delta t minus a, then it is equals to fa, because you just take this function. Your function is ft now, okay, and the answer is still ft, but you replace this t by a. Okay, now let's go to the Laplace transform of direct delta function. Laplace transform of delta t minus a. So Laplace transform of delta t is equals to 1. Laplace transform of delta t minus a is equals to e negative as, and the Laplace transform of ft delta t minus a is given by this function. Okay, so I'll prove these three functions below. Firstly, I'll prove this one first, and then the second one, and this will be the third one that I'll prove. Okay, so firstly we'll prove the second equation. Okay, Laplace transform of delta t minus a is equals to, okay, so before I proceed with this one, okay, let's recall back what is the definition of Laplace transform. So let's say you have a Laplace transform of ft. What is the formula? Laplace transform of ft is equals to the improper integral from 0 to infinity e negative st ft dt, right? So you have e negative st here. Okay, so same goes with this one. You will have the improper integral of from 0 to infinity e negative st delta t minus a dt. Okay, so we know that the Laplace transform, the improper integral of ft delta t minus a dt just now is equals to this one. Okay, the improper integral of ft delta t minus a dt is equals to fa, right? So this one is equals to fa. Okay, then from here, so it is equals to 0 to infinity e negative st delta t minus a dt is equals to, okay, now if you have this kind of function, okay, you just copy the function, but you replace t with a. So now you just copy the function of exponential function here, and you just replace t by a. Okay, negative as. So it is proven that the Laplace transform of the delta t minus a is equals to e to the power of as from here. Okay. Okay, now the second formula that I'll prove is this one. The Laplace transform of dt delta t is equals to 1. So So the Laplace transform of delta t is equals to, from the definition, from 0 to infinity, e negative st delta t dt, right? So this is equals to e negative st. So this t delta, this t is actually t minus 0, right? So t here is actually equals to t minus 0, okay, dt. So it is equals to, when you have okay, from here, when you have this function, you just copy the function, you replace t by a. Same goes with this one. If you have a function times delta t minus a, then you copy back the function, but you replace t by a. Same goes with this one, right? It is the same. It is the same same form. Okay, a function times delta t minus a. So, but for this case, your a is equals to 0. Here, your a is a lah. So that's why you replace the t by a here. Okay, so you will have e negative s t is 0, which is equals to e to the power of 0, which is equals to 1. Okay, so it is proven that for the first formula, Laplace transform of delta t is equals to 1 from this derivation. Okay. Okay, now let's go to the third one. The third equation is the Laplace transform of ft delta t minus a is equals to improper integral e negative st ft delta t minus a dt, right? From the definition of Laplace transform. Okay, so now from here, let's substitute with other function. So let's say we let gt equals to e negative st ft. Alright, so now we have in the integral of gt delta t minus a dt. Alright, so same with the these two formula. If we have this one, the improper integral of ft delta t minus a, it is equals to fa. So you copy back the function, but you replace t by a. So this is equals to ga, right? So g is this function. So it is equals to e negative as fa. Okay, so it is proven for number 3, for the formula number 3, right? So this is the Laplace transform of direct delta function. Okay, now let's go to the example. Okay, example 14. Find the Laplace transform of ft if ft is equals to e negative 2t plus delta t minus 2. So for this one, it is actually equals to f, the Laplace transform of ft equals to the Laplace transform of e negative 2t plus the Laplace transform of delta t minus a, right? So the Laplace transform of e to the power of negative 2t you can get from the table. So from the table, if your ft is as e to the power of as, then your fs, or the Laplace transform of this function, will be 1 over s minus a. Okay, so this one, it is equals to 1 over, your a is negative 2, so s minus negative 2. Okay, plus, for this Laplace transform of delta t minus a, so you can refer the previous page. T minus a, it is equals to e to the power of negative a. Okay, so it is equals to e to the power of negative 2s. So the answer will be 1 over s plus 2 plus e negative 2s. Okay, so I hope you can understand this example. Okay, example number 15. Find the Laplace transform of this function. So this function is actually mapped to the Laplace transform of ft delta t minus a. Okay, so the Laplace transform of the ft delta t minus a is equals to e to the power of negative as fa. Okay, now for this question, our a is pi over 2, our ft is equals to t cube. Alright, so for this question, this is the answer actually. So we want to know what is fa. So fa is equals to f, your a is pi over 2. Okay, so f pi over 2 means that you just replace pi over 2 here at into t. So you have pi over 2 cube, it is equals to pi cube over 8. Okay, so the Laplace transform of t cube delta t minus pi over 2 is equals to e negative as fa. So e negative pi over 2 s times fa. Fa is pi cube over 8. Okay, so you can rearrange. So you have pi cube e negative pi over 2 s over 8. Alright, so this is how to do the direct delta function. Okay, example 16 now. Find the Laplace transform of sine 2t delta t minus 2. So the same, this is mapped to the Laplace transform of ft delta t minus a equals to e negative as fa. Okay, so for this question, our a is equals to 2 and ft equals to sine 2t. So fa is equals to f 2 is equals to f2a means that you replace 2 in t. So you have sine 2 is equals to sine 4. So the Laplace transform of sine 2t delta t minus 2 is equals to e to the power of negative 2s fa. Fa is sine 4. So this is the answer, right? So that's all for subtopic 3.4, and I'll see you guys in the next video, which is subtopic 3.5. okay?